Now it's definitely videoing.
Yeah,
One, two.
Yeah.
Just have a look over it every now and again to make sure it's still in video. Okay, everybody. So, number one, yesterday's video didn't come out because the thing ran out of memory, so I only got the first 10 minutes of it. So I'm going to go over some of the stuff from yesterday as well. I put up the inferior version of yesterday's lecture, which was the one that I did for the 228s. Alright, so your one was better. So anyway, I'm going to just summarize what we did yesterday. Abstract classes on our first little XNA example. And if we have time today, we'll move it on a very small bit by looking at how to do rotations. And then I need to go to a course team meeting at about 20 to 2, so we'll have to finish a little bit early today. So I'm going to lash through this pretty quickly. I've been given some thought about the assignment and how we're going to do the assessment and stuff like that, but I think we'll talk about that next week, right? So, anyway, from yesterday, what I wanted to try and do here is just, number one, add a piece of content to this, and I'm going to add the Sprite content. So if everyone can remember, you click Add Existing Item, making sure to add it to the content part of your project rather than to add it to the where the code goes. And I'm going to just find the little tank that we used yesterday. Courses, game engines, tank game. Content, and there's the small tank sprite. Alright, so I'm going to add the sprite to my project. So just to recap, just to remember that you added to this part of the project, the content part of Visual Studio, not this bit up here. Alright, and then it gets put into Visual Studio and compile that into your project, right? So what I want to do is, let's see, we did the abstract class yesterday, didn't we? Right, let's do an abstract class. Well, yeah, let's do an abstract class. No, in fact, let's see what you do here. We're going to add a class anyway. Let's do this iteratively, right? Let's first of all think, I want to add a class to this project to keep track of the tank. Alright, it makes sense that when you're looking at particularly a game, you look at the things on the screen, and everything that's on the screen you make a class out of to encapsulate the behavior and the functionality and the state for every object on the screen. That's, I think games are a great way to understand OO, because there's typically a class for everything that you see on the screen. Right, and that's a good rule of thumb. So I'm going to make a tank class. So what does my tank class, what data does my tank class need to hold? Position. It needs to hold location. Anything else? Yeah, eventually, definitely, all of that stuff. The things like the health, the amount of ammunition that it holds, all that stuff is eventually here. Just for today, I'm going to put a very simple thing together. I'm going to put in public vector2 for position. Now, this is a thing which is slightly weird. Watch this, by the way. If you notice that this doesn't have the right using statements at the top of the program. This should have using Microsoft.xna, to say that it's using the classes from the XNA namespace. But what you can do is you can right click on that, click on resolve, and then it says put in the right using. So it puts in the right using statement for you like that. Alright? Typically as well, for things that we make fields of the class, we make them private and we make a public getter and setter. Right? So we make a property out of it. But this is a weird thing in C#, and I found this kind of confusing myself when I started it. First of all, you can't do that for a thing called a vector2, because a vector2 is a struct, not a class, and a struct is what's called a value type. So that means that you get a copy of the object, not a reference to it. It's not an object anymore. So what I typically do for things like position, anything that's a vector2, I make it public. Alright, so rather than make it private and do an accessor, if it's a class, a reference to another class or a reference to another object, I'll make it private and do a getter and setter. But for vector2, you have to make it public. So it's got a public position. Let's add one other thing here, and I'm going to call this one look. Right. So we're going to do this. We might as well do this, right? This is the first bit of game maths that we need to know about, and this is a little bit of trigonometry. How many people here did trigonometry in primary school? How many people did trigonometry in secondary school? How many people can remember trigonometry? Okay, so I know, and I don't expect you to, by the way, because even in my fourth year game engines class, the very first week we revised the trigonometry that people would have done before. Are you familiar with the concepts of sine and cosine and tangent?
Yeah.
Right, okay, that's good. Right, so what about the unit circle? Is that something that you might have come across before? How many people have come across the idea of the unit circle? Just put up your hands nice and high so I can see. How many people have never come across the idea of the unit circle in trigonometry? That's cool. Don't worry about it. Right, we'll do it. I'll tell you what, just before I go and do the unit circle thing, what methods should the tank have? Huh? What methods should the tank have?
Shoot.
Yeah, what should it have? Shoot, okay. Let's imagine that we're going to build this iteratively. What's the bare minimum that the tank needs to do? What's that?
Move.
It needs to move. Okay, so where should I put that? Should I put a method called move? Or what am I going to do in that method? I'm going to probably check the state of the game controller or the keyboard and decide to update the object's position based on that. Here's a better way to think about it, right? In X and A, we've got four sort of core methods. There's initialize, there's load content, there's update and draw. So I think it's a good idea that absolutely every object in my game implements those four methods. Alright, so a tank can update itself, a tank can draw itself. And then anything else the tank needs to do, like shooting and stuff, that's going to be specific to the tank. So what I'm going to do is I'm going to put in a, because the tank needs to load its sprite. By the way, how do we represent a sprite in X and A? Texture 2D. Alright, so this one I'll do the right way. I'll make a private texture 2D. Alright, and again you get this problem that I haven't imported the right reference, so you click resolve using Microsoft.xna.framework.graphics. So that's where it gets texture 2D from. That's just a namespace, by the way. Somewhere in the DLL for this, somebody has written namespace Microsoft.xna.framework.graphics and put the class texture 2D into it. That's all that somebody has done. And if you leave that out, by the way, I don't know if you know this already, but you can leave that out. And what you can do then instead is you can type the full namespace thing. Microsoft dot xna dot framework dot graphics dot texture 2D. There you go. So they do the same thing. The reason why you put the using in is it just saves you having to type all of that every time. So you just go using, there we go, oops. Again, I'll just resolve the reference. Resolve using Microsoft Framework. Okay, so that just saves you typing all that. Let's put a sprite in here. And then let's do the next thing, which is, let's say that this tank at some stage is going to have to load the sprite. So why don't we put that into a method called load content to be consistent. So public. Now you'll see next week when we sort of make a little OO framework for this, that this makes complete sense. That we try and retain this kind of structure throughout our program. And by the way, what's a good way to make sure that everything implements load content, update and draw? Can anyone think of a good way to make sure that every class in our game implements those things? From yesterday's lecture, is there anything? That we guarantee that everything in our scene implements load content, update and draw. Is there any way that we can guarantee that everything does that? Make an abstract class. Fantastic. So we make an abstract class that everything extends. And we remember from abstract classes, if you extend an abstract class, then that means you've got to implement all the methods in the abstract class. So that's what we'll do. So I've got a load content, and in the load content, I need to get access to the content which is part of game 1. Now, this was a little trick that I showed you yesterday that I really like. Public static game 1 instance, and then in the constructor you go instance equals this. The static here means there's only ever one of these created, regardless of how many objects is created. In fact, you can make this private, and then you can also do a public public game 1 and static as well, because I want this one to be static. And you can go get, and we'll do a getter for it, and we will return. Why aren't you lining up correctly? We'll just return. Sorry. That's why. Alright. So this is a little trick, right? This is what, in programming terms, this is called a singleton. I'm presuming that there's only ever one game. Alright? When the program loads, it creates a game. And the constructor for the game is going to get called, right? But the game, if you notice, keeps track of things like the content and the sprite batch. So we need to keep track of the game. And we need to get access to those things from other classes. And this is a trick to allow you to do that. You make a static thing, which is an instance of the game, the reference, and then you make an accessor for it, and you just return the reference to the instance. And because it's static, that means it's a class variable rather than an instance variable. And then in the constructor, you just go instance equals this. We did that yesterday, just right towards the end of the class. That's a little trick. And that's just something that you need to probably put into every single XNA project that you're going to make. I really like that, because that means now over here, to get access to the content, I can just go game1 dot instance. So I can use that static property on the game1 class, right, to get access to it. Alright? And then you can get access to all the various things like the content. So content.load TEXTURE texture 2D, and then you give it the file name, which we call small tank. And so that's that load content, and then we need an update, which takes an instance of the game time. So we'll make this match the one from the XNA game class. And in here I'm going to put all of the movement code. Alright, so I'm going to check the keys. I'll just put a few very simple keys here, right? I'll basically get... Can anyone remember how you get the keyboard from yesterday? How you figure out what keys are pressed?
Gamepad state.
Yeah, exactly. That's how you get the gamepad state, but it's keyboard state to get the key state. It's called... I'll need to basically import the reference. What I'm going to do is just copy and paste all of the using statements up here into this one, so I get all the references. Control C, bring this guy into here, and then I'll just paste all these guys into here so that I get better code completion. So scroll down to here, KEY keyboard state, KSTATE, this is the variable, and it's of type keyboard state, equals, and you use the static keyboard.getState. So that's a static method on the keyboard class. There's no keyboard instance created. You can still call the method because it's a static. It applies to the class rather than an instance. And then you can check the keys. So you can go if kstate dot is key down keys dot let's basically just do the arrows keys. Now let's do something cool here. Let's make our tank rotate. So the up key, what do I want to do to the position when I press the up key? I want to do something with the Y. I want to subtract some value from the Y. So we did a little bit of this yesterday, where I basically declare a variable called speed. And we'll say that I want to move 100 pixels a second. And then the other thing you need to declare here is the time delta. Game time dot elapsed game time dot total seconds. And then we need to cast that to be a float. Alright, so that tells you, what does time delta tell you? How much time has elapsed since the last time update was called. So in your game, if your game is updating the scene 20 times a second, you'll get a value of 1/20 for that. So that's how much time has elapsed since update was last called. Alright, and then you can use that to do the speed thing. So this is like a car travels at 3 meters per second for 1 second, it's gone 3 meters. For 2 seconds, it's gone 6 meters. So you take the speed multiplied by the time to figure out the distance you want your sprite to move. So we can take position dot y minus equals to speed multiplied by time. And then let's do the same thing for the down arrow. So keys dot down. And then in this case we want to add something. So now we're moving up and down. And then the last thing, let's draw the sprite. And this also takes an instance of the game time. Now, if you remember from yesterday, to draw it, we have to call sprite batch.begin. You call the drawing code, and then you go sprite batch.end. So that's how you draw stuff. But in this example, I'm going to get the game 1 to call sprite batch.begin and sprite batch.end. So the tank is just going to draw itself. Alright, so what you have to do is go game 1, because you have to get in access to the game1.instance and you're going to get access to the sprite batch. So in order to make that happen, you have to make the sprite batch a public. So there's the sprite batch dot draw. Now, I'm going to use a different version of the draw today. Well, in fact, let me just draw it normally first, and then I'll change it around a bit. So then you go sprite. The next parameter here we're going to use is the position. And then finally the tint, which is just color dot white. And then that's that. And then over here in game 1, we're going to create an instance of that thing. So we call that one tank. Alright, because otherwise when you run the program, nothing's going to happen. I've created a class, but I've never instantiated the class. So therefore, it's like saying there is a tank, but there's this concept of a tank, but I don't have an actual tank. I'd like to have an actual tank. But I don't have an actual tank until you go tank equals new tank. Which you can do anywhere you like, but it's a good place to put it in here. Now, to make sure that that code gets called, you then have to go and call the load content in here to make sure that it goes and loads its sprite at the appropriate time. And then you have to make sure that it goes and updates itself. So I'm just calling the method on the tank instance. And then down here we have to make sure that it draws itself. So we can call tank.draw. And then in here we need to call the sprite batch begin and the sprite batch end. So this is pretty much a recap of stuff we did yesterday, but I've just taken the code out of the game 1 class and put it into a different class. So now we should be able to run this thing. So let me hit F5 and I should hopefully have a little tank. What's wrong?
That's right. No, it's small. Tank, small.
Small tank.bmp. Small tank.
Did you pass the Sprite?
Oh, sorry. Okay, that's what it needs to look like. So now we've got a tank which could go up and down. And the initial position is 0, 0. It's kind of ugly. So let's make a couple of minor changes to make it look slightly less ugly. First of all, I'll get rid of the corn flare blue and make it white. And then over here in my tank class, I will give it an initial position, right? So here we go. I've got a tank that can go up and down. Alright, so yesterday we put in code to make the tank go left and right. This time I'm going to put in code to make the tank rotate. And here's where the little bit of trigonometry comes into play, right? So the very simple code that we can do here is... okay, how you tell things to rotate in X and A, it's just a variation of the draw code. And you just pass in an angle that you want, when it's drawing the sprite, you want it to rotate the sprite by a certain amount. So the first thing is the amount of rotation we specify in what? Degrees would be nice, but no, it's not degrees. Radians. It's specified in radians. What's a radian? How many people know what a radian is? I bet you did this for the Leaving Cert or the Junior Cert or in primary school. Is it just, how many people definitely did it at some stage but just don't remember? That's absolutely fine. I'll explain what it is, right? But let's make it rotate and then I'll do the explanation bit, right? In fact, I'm going to put all the code in here and then we'll put the explanation bit in afterwards, right? First of all, okay. So that's the first thing, the rotation amount. So instead of using this version of the draw, I'm going to use a different version of the draw. And what I'm going to do here is just look for a version that allows me to rotate the sprite. So I'm going down here, and there's one. Look, this is a version of the API that says, yeah, destination rectangle, source rectangle, color, rotation, origin, sprite effects, layer depth. So that one might work. Is there any nicer one that doesn't take the rectangles? Yeah, here's one that doesn't require the rectangles. So this one takes the sprite first of all. The second parameter is the position. The third parameter is the source rectangle, so I'm going to pass in null for that one. The next one is the color. What's that? Color to tint a sprite. Okay, so that's going to be color dot white. The next parameter is the rotation amount in radians. All right, so this is by how many radians you want the sprite to rotate by. So I have a float which I'm going to pass in for that. The next parameter is the origin. So I'm going to just pass in vector2.0 for this for the moment. Okay, vector2.0 is the static on the vector2, which just is the vector 0 and 0. So it's a static member of the vector2. It's a static field. And then the next one is the scale. I'm going to just pass in 1 for the scale. Finally, sprite effects dot none. And then final one is the layer depth. I don't think it really matters what you pass in there. Now, let's run this and see what happens. Oh, I haven't actually done any rotation bits here. Let's put in some code to rotate this thing. So I'm going to copy one of these things here because I want it to rotate when I press the left and right arrows. So when I press the left, what I want to do is I want to take something off rotation. Minus equals to speed multiplied by the time. And when I press right, I want to increase the amount by which I rotate it for. GHT. And then we hit F5 to run in the debugger. Is everyone excited? You don't sound very excited. Give me some excitement here. Oh my god, look at that. It's rotating. So but there's loads of things wrong with that rotation. Okay, number one thing that's wrong with that rotation is it's way too much. It's way too fast, alright? Let's instead of actually taking the speed, which basically multiplies everything by 100, let's just take the time delta, which is going to be a really small number. Okay, now it's rotating a little better. The problem is, though, what's the problem? Can anyone spot what the problem is?
Position where it's rotating from.
Yeah, it's rotating around the top left-hand corner of the sprite. So in X and A, all coordinates and everything are all done from the top left, right? So there's an extra parameter to that rotation code, which is this thing down here, and this basically tells you where you want to rotate around this command of the origin. When you specify vector2.0, it uses the coordinates on the sprite of 0, 0 on the sprite to do the rotation. So what should we really pass in there? Center point of the sprite would be better. Alright? So we can do this like this. Vector2 center equals new vector2. Center.x center.x is going to be equals to the width of the texture. Now, how do we calculate the width of the texture? Anyone, any ideas? I haven't done it, but what would you think? Huh? Yeah, it's going to be in pixels. How would you do it?
100% of whatever the image is.
I know, but how would you know how big the image is? What's that? Yeah, definitely. It's going to be half the width and half the height. How do you know the width of the texture? Yeah, so any ideas how might we even Keep going. Sprite dot height and sprite dot width. So they're properties of the sprite. Do you kind of get what a property of something is now? So there's a sprite thing there, right? And it's built into the sprite class, to the texture 2D class. Look, you've all of this stuff, bounds, and you also have width. There you go. So there's a property of the sprite which tells you how wide it is. That's what properties are for. You can see how something like that is kind of useful now. This is the same way when we made a line and we made the slope and the intercept, you know. So somebody has pre-written this thing which calculates the width for you. So you can just go the center.x equals the sprite.width divided by 2. And the center.y is equals to the sprite.height divided by 2. And then you pass in, instead of passing in vector 2.0 as the center point there, you pass in the value that you've made. Now watch what happens when we do our rotation. So we can move up and down, and now we can rotate like this. I'm rotating around the center of the sprite. In fact, for this sprite, the center is probably not what I want to rotate around. Because you have this big turret sticking out of the front of the tank, you know. But you get the idea. You know, you can fiddle with it a little bit more. So I need to go to this course committee meeting thing. Is there one small thing that we can do to add to this? I think there is. I can explain to you what a radian is. And then in the next class, we have this challenge, and we'll have to use trigonometry to solve this, right? I need to rotate it by a certain amount, but when I move, I don't want it to move up and down anymore. I want it to move in the way it's facing. So we have to use a little bit of trigonometry to do that. And you might already know this, and when you see it, it should be, you know, pretty self-evident. Right, a radian, a small bit of maths, right? Oh, that's a big bit of maths, yeah. Has someone got something for cleaning the board with? A pen. Just a page, I think, yeah? I don't want to ruin somebody's scarf. Thank you. So the other thing I'll do is there's absolutely brilliant Wikipedia articles and things on the net and very nice Khan Academy YouTube videos which explain any little small bit of maths that we need. So I'll put those on the course website. Great. So here's the thing. Okay, first of all, okay, in X and A, in 2D, this is a rotation of 0 degrees. If you tell something to rotate by 0, it means no rotation. Other than that, we can basically specify an amount of rotation in degrees. Okay, so if I was to specify rotation from straight up all the way around, how many degrees is that? That's 90-degree angle. Okay, if I go all the way, if my thing is pointing straight up and I tell it to rotate all the way to straight down, it's 180 degrees. So I have 90, you've got 180, all the way over to there, 270 degrees, and all the way back up again. So if you tell something to rotate 360 degrees, it's the same as no rotation. Alright, so there's 360 things here. If you say rotate by 0 degrees or by 360 degrees, it means no rotation. Is that fair enough? The next question then. It depends. That's a very interesting point. In X and A, right, the update and draw, the way they work, is they're basically going to just get called once per frame. So if you tell something to rotate by 360 degrees, it will just get drawn 360 degrees rotated. There will be no intermediate thing like this. Unless you say rotate by 0 degrees, then by 1 degree, then by 2 degrees, and you'll see it transitioning slowly. You follow? Otherwise, it just flips it, and it draws it flipped. Follow? Or not flipped, as the case may be, in 360 degrees. The next question, are the rotations clockwise or anti-clockwise? In X and A, the rotations are clockwise. For 2D, for 3D, the rotations are anti-clockwise, rather confusingly. But if you tell something to rotate by 45 degrees, then that means it's going to point up there, and that's a 45-degree rotation. Okay, the radian. How do you calculate the circumference of a circle? The other one. 2 pi r. Alright? So let's write this in terms of units of things of the circle, right? So if I said that that's 0 units of the radius, this thing as far as here in terms of units of the radius, the circumference, if you start there and you walk all the way around until you reach there, you will have gone 2 pi multiplied by whatever the radius of the circle was. Let's make this a really simple thing, and let's say the radius of this circle is 1. So if you start here, it's 1 meter, okay? If you walk all the way around to there, you'll have walked how many meters? 2 pi meters. That's what it means, the circumference of a circle, right? 2 pi meters from there to there. If that's 1 meter, it's 2 pi. If this was 10 meters, how far would you have walked? 20 pi meters, right? So that's 2 pi or. Now, if you want to walk from there to there, how far would you have walked? Well, we'll do the simple one. If you want to walk from there all the way around to there, how far would you have walked? You would have walked pi, wouldn't you? Meters. Because if it's 2 pi from there, halfway is pi meters. Isn't that the case? If you want to walk from there, from 0 as far as there, how far would you have walked? You would have walked pi over 2. And if you want to walk over as far as here, how far would you have gone? It's basically 1.5 pi. You know, isn't that right? So it's 3 over 2 pi, isn't it? Isn't that 1.5 pi? Yeah, that's 3 over 2 pi. So that's how far you would have walked. If you want to walk this far, how far would you have gone? Pi over 4. That's radians. That's all there is to it. It's units of the radius. So pi over 4 radians corresponds to 45 degrees. Pi over 2 radians is 90 degrees. Pi radians is 180 degrees. So then, actually, there is one small other thing. How do you convert between radians and degrees? Okay? We'll say given 80 degrees, how would you convert that to radians? Of course. I mean, just mathematically, because you will have to write a code to do this. 80 degrees to radians. 360 degrees to radians is what? Is 2 pi. 90 degrees to radians is pi over 2. How do we convert? You know, 180 degrees is pi. How do you convert from 80 degrees to radians?
1 over 80 multiplied by 2 pi.
Say again?
1 over 80 multiplied by 2 pi.
1 over 80 multiplied by?
2 pi.
Why 2 pi? 2 pi is 360. So 1 over 80 multiplied by pi. So okay, so you can think, right, 360 degrees is 2 pi. I mean, this is just a little, hopefully, obvious stuff, right? I mean, I can give you another example which doesn't use radians, you know, just to say 100 apples costs 200 euro. How much does 50 apples cost? You could work that out, couldn't you? You're going to take 100 divided by the cost, and then you multiply it by the new thing. So this is exactly the same problem here, right? So you basically just take 80 divided by 180, and then you multiply by pi, and that's how you convert from degrees to radians. So if you think 180 divided by 180 is what?
180 divided by 180.
Is 1 multiplied by pi is pi, isn't it? Is that clear? Don't go quiet on me here, guys. This is very, very basic maths. I hope I'm not scaring anybody here by doing this. Otherwise, we're all in trouble. Right? To do the other way, if you were to take, let's say, 0.3 radians, and you want to convert that to degrees, you basically just take 0.3 divided by pi, and you multiply by 180. 180, right? All I've just done there, of course you can do 2 pi, and you can make that 360. It's just, I'm just dividing both sides by pi, you know? Just to keep it simpler, you just take that multiplied by 180. And if you don't understand that problem, I'm going to write up a very small one, and just spend a bit of time between now and the next class thinking about it. 300 iPods can be purchased in a job lot for 200 euro, okay? They fell off the back of a lorry. But I don't have 200 euro, I only have 50 euro. How many iPods can I buy? So work that problem out and tell me in the next class. Okay?